are a lot different as far as their graphs are concerned as sines and cosines. Now you guys are probably fairly comfortable graphing a sine or cosine graph by doing the parent function and the shift, getting the amplitude, the period, and all that kind of stuff. Tangent graphs are a little bit different, whereas they're based on, they're based off the quadrantals. These, I take the tangent stuff as far as their parent graphs, which come from 14.1, and then we also do the shift part, which is in 14.2. So I kind of combine both of them together because, let's be honest, tangents, there's really not that much going on with them, so there's no need to kind of, but they're so much different than this, I like to just separate them. That's why I do it this way. So if I go back and think about a tangent graph, I go back to our good old-fashioned friend, the unit circle. And I build it off of the quadrantals, exactly the way that we did sine and cosine. So if I do that and list my ordered pairs, 1, 0, 0, 1, negative 1 and 0, and 0, negative 1. We get those. If I'm going to graph tangent, I know that tangent is y over x. Okay? I know that's what it looks like. So as I go through my ordered pairs, I'm looking at not just the x values or the y values, I'm looking at them divided out to figure out their placement. So if we start this out on a regular old graph, tangent at 0 is 1, or excuse me, it's 0 divided by 1, y divided by x. What's 0 divided by 1? 0. What happens at pi over 4? What's the tangent at pi over 4? 1. Very good. Tangent at pi over 4 is 1 because it is root 2 over 2 and root 2 over 2. You okay with that?
Okay. Sure.
What about it? Negative pi over 4. It's root 2 over 2, negative root 2 over 2. What is that? Negative 1. Okay, so you have those 3 points so far. Continue, going back up to here at pi over 2. Tangent is y over x. 1 divided by 0. Undivided. So at pi over 2, we have, oops, close to matching that up. We have an asymptote. What happens at negative pi over 2? It's undefined as well.
Okay, whatever.
So here's what's happening. Tangent graphs hug an asymptote until they get to pi over 4, go through the origin, and cut back through.
That's all I do.
That's all they do.
They look nothing like sine and
No. They're not continuous because they have the asymptotes. They repeat every pi value. Because if you watch through on a tangent graph, remember when you solved for tangent, you had open circles here and here? Because there was an asymptote, because you couldn't get a tangent value at pi over 2 or negative pi over 2. So each time you're coming around, you get to an asymptote, come back around, asymptote, asymptote, asymptote. So as you cycle through this, your tangent graphs are always just going to look like.
So there's only so many you can do?
Yeah. Well, you can do an infinite number of graphs, but you're only going to look at the tangent graph between one set of asymptotes, one period value.
Will ever flip around? Like,
Yeah, they'll
will ever be that way?
They could if the A value is negative.
Okay.
Okay. It just goes the other direction, just like sine and cosine does. So with tangent graphs, you still have the same generic looking formula as far as their parent is. You have y equals a tangent b of x. Where this A value, it's not technically called the amplitude. So I usually, in a tangent graph, I call it amp with parentheses, air quotes on it, because that's where it changes direction at the amplitude. So if it was 2 tangent, instead of changing it at 1s, it changed it at 2. It'd just be stretched. That's all. So this is think of this as the change. Change of direction spot. When you do a couple of them, you'll see it. Oh yeah, it's not technically an amplitude because it's not a maximum or a minimum. It's just where it's changing direction. All right. Your B value still allows you to find period, but your period for tangent is different. The period is going to be pi over 2, pi over the absolute value of B. So it's pi over B. Because tangent has the asymptotes into the circle, so you're only going to look at half of it at the time. We still use that absolute value of B, even though you guys probably will never see an absolute, a negative B value in this class. It's not to say it doesn't exist, but. And the last little bit is the asymptotes. And I'll show you guys a real nice, easy way to figure out where the asymptotes go after we've plotted a couple of them with some shifting. You'll probably pick up on that. So really what happens with tangents, you get 3 points. The origin, 45 degrees, and your asymptotes. The period is the distance between the asymptotes. I don't think there's a P in there, is there? Did I spell that right?
S.
Yeah, you did.
I did?
Maybe
Probably.
the M and the Y.
Yeah, the M and the Y might be switched, but
I think the M and the Y are switched.
No,
S my toes.
I mean, like, who really cares? It's the same word. That's all.
We know what it means.
Everyone knows
That's
what it means.
No one
So yeah, your period is always going to be the distance between the asymptotes. So your distance between the asymptotes is your period, which means halfway between that is going to be where it goes through the origin. Halfway between the origin and the asymptote is where it changes direction on either side.
It'll always
It's-
be half
Yes,
for
sir.
that.
Yes, sir. Why? Why?
Yeah.
Because that's how it works. With tangent, you have, if you think back to the order, what do you call it, unit circle. Half of the graph is up here, and the other half is here. When it crosses the origin, you get one half and the other half.
Okay.
So this side is half of the period. This is the other half of the period
Yes.
because of that.
Okay.
Yes, ma'am.
So does it always change directions at like whatever 0?
It crosses through there, yes. Yep, that's where it crosses through. You're always going to have these 3 points and 2 asymptotes. As opposed to sine and cosine, you had 5 points.
Wouldn't the point where pi wouldn't be pi determined by A? Isn't that what you said? So
That's exactly what it is, because A is going to be a scalar again. A is going to be some sort of scalar. It could be anything.
so
So-
the point would be pi over 4, and then the y value would be A.
So
If there's no B, it depends on your period.
If
We'll
there's
get,
no
yeah.
period.
Yeah.
So will like the pi over 4 and the pi over 2 change? Or
Yes.
does it change?
Yeah, it changes with period, just like it did with sines and cosines. So let's look at an example. Y equals 3/4 tangent of 4x. That's 3/2. I was looking at, I was just looking at the 4, sorry. G, do you think we're going to start by labeling out what we know?
Yes. Yeah.
Convenient. A, 3/2. B, 4. You're supposed to say and after. You guys ever play bingo?
No.
When they say before, people would say, and after.
How old are you?
Because
That was good.
that was good. So our amplitude is 3/2. Our period is going to be pi over 4. So that means the distance between the two asymptotes are pi over 4. Since there's no shifting here, that means I'm going to go through the origin. We haven't introduced an h and a k yet. So all of these are going to go through the origin. Now, if my period, my distance between the two is going to be pi over 4, and half of it is on one side and the other half is on the other, where does that place my asymptotes? An eighth, yeah. So basically what happens here is to get your asymptote, once you know your period, you cut it in half, and that will place your parent function's asymptotes. The distance between the asymptotes is the period. If the period is pi over 4, half of it is on one side, the other half is on the other. Half of a fourth is an eighth, half the other way is a negative eighth. You still have an overall distance of a fourth. Okay, so this is still at 0. What's halfway between negative pi over 8 and 0? Yeah. And then on the other side, it's the same thing. It's pi over 16. Our amplitude, 3/2, or negative 3/2. Our a value is positive, which means tangent is increasing going from left to right. So I just mark the 3 dots. And away you go. Yeah.
How do you know that it's going
A value is always, when a value is positive for tangent, it's always increasing from left to right. If it's negative, it goes decreasing from right to left. It's just reversed.
so And last bit, asymptotes are at plus or minus 1/2 times your period. Your asymptotes will always be at plus or minus 1/2 your period. That's it. Tangents are really nice. But you better use sunscreen.
Can you explain it?
No. Skin cancer is bad.
Oh, I get it now. And
We'll do one more real quick and then I'll show you the shift. Don't humor me, it's not worth it. But thanks.
it was kind of funny, I'm not gonna lie. I'm not, just saying.
Well, I
I like
appreciate-
corny jokes.
I appreciate it. That's nice to ear. Get it? Corn? Ears
Yeah.
of corn? There's no offense to you.
I know.
I wasn't being mean.
It wasn't mean, it was fun. It's only mean. It's only mean if he thinks it's mean.
What's your A value?
He does stuff. 4.
Your B value. So your period is 1. Probably had a couple of these yesterday where your pi would just simplify out. That happens. It's not a big deal. It's still a trigonometric function. You're still going to get the curve. You're still going to go through because it's a scalar. Okay. So we go to graph it. If the distance between the asymptotes is going to be 1,
I drew a sine graph.
and half is on one side and half on the other, what do you get? Oh, there's no pi though, it's gone.
Oh, wait.
Because your period's 1, so half would be over here, the other half is here.
So you still have.
See you later.
What's that?
I said I'm used to that.
Pi would be pretty good.
Yeah, like apple.
Pumpkin
I haven't had a French silk pie in a while. That would.
It's pretty good.
French
It's
silk pie.
pretty good.
Peanut butter. You ever had peanut butter cup pie?
I've had
That sounds really good.
sweet potato pie.
Toenail.
Love it.
My wife made a peanut butter
All one.
cup pie once.
Tangent style noodles.
What's that?
Isn't it supposed
That's
to
what I
be
think it was.
Did you say
Never.
candy style noodle?
Yeah, they look like noodles.
I took the negative out of the times, right?
Would you eat? Oh yeah. What if you went to a restaurant and they were like, "Would you like some Cajun style?" I was like, "Please."
I mean, maybe. Is there anything else in the menu?
I don't know. What do you think tangent in the food world?
Dude, I don't think tangent is in the food world.
Is tangent in the food?
Oh God, the things we talk about sometimes, I just don't get it. Just wait till we do like the actual like fun stuff.
We haven't done fun stuff.
No, I haven't taught you guys how to gamble yet.
Yes, that's coming soon.
I already know how to game.
I will
Alright.
dust you.
Actually, I'm not very good.
What kind of term is that?
When do we do that?
I'm damn.
We have once we're done with trig, we come back from spring break. We will do sequences and series. That takes about a couple 2-3 weeks, and then we do probability. And then in probability, we start doing about cards and things like that. What's that? It's one of the last things we do. Depending upon how much time we have left, we probably will do some matrices. Matrices? No, actually, it's all calculus. It's kind of boring, but oh, we have modeling to do still too. I forgot about that. Nuts. We'll make it. Shifts. Gee, look at this. AH and K again. Go figure. What do you think the H and K stand for?
We're to coal.
Once again, all you need to worry about is that you have a shift left and right and up and down. So when you're shifting left and right, you're going to have to move your asymptotes. You're going to have to move your ordered pairs. But when you shift an asymptote vertically, does it change the asymptote? So in these cases, when you have your asymptote, since we have vertical lines for asymptotes, or vertical asymptotes, I should say, it's always going to be x equals some number. So when you list these things out, you don't have to worry about shifting them vertically because it's still the same x value. Graph, like we've done before with the AH and K, it's just a matter of spacing it out a little bit extra so you have a little bit of room to show it. Can't think of really any. You're adding fractions still. Doesn't really change up a whole lot.
A whole lot.
So let's start with this one. Y equals -2 tangent quantity x plus pi over 4 plus 3. So let's add a b value.
Okay. 1.
We'll use 2. Might as well. Just throw it all in there at once. No reason to have to, just jump in, right?
Yeah, exactly.
Jump in head first.
Best way to learn is
No need to test the water. It's going to be cold. You'll be fine. So we start with a list. A is -2. B is 2. H.
Negative.
Very good. -pi/4 and a k of 3. So I'm going to go left and up. A value is negative, so which direction will this be going?
Down.
Down and right. So a lot of times what I would do when I know that it's negative, I would just draw this out so I don't screw it up. It just means that my amplitude-ish thingy is still 2.
That's still the absolute value.
Yeah. That way you know your points are at 2 and -2. For the parent function. Your B value gives you your period. Your period is going to be pi/2. So the distance between my asymptotes will be at pi/2. Therefore, both my asymptotes for the parent are at and. Very good. So you have pi/4. Negative pi/4. Halfway between 0 and pi/4 is plus or minus pi/8. And like we said earlier, it's working its way down. Okay.
Oh, sorry. Okay, so the
Oh, yeah, the only thing that A does is decide whether it goes this way
Yeah.
or this way.
That's the same thing, the only thing that A did over here as well. A is still where it's changing direction at the halfway between the origin and an asymptote. It's still where it changes the direction, but it also tells you what direction it's moving, if you're going top down or bottom up. Same thing with sine. You remember sine, you start at 0, go to your A, whether it's positive or negative.
Yeah.
Cosine, you start at the A, whatever it is, and go to 0, then go the opposite. That's the same idea. Yes,
so A is just the y-axis, how much you go up and down.
Yes, sir. That's why we call it the amplitude-ish, because it's not a maximum, it's just a point of inflection. I think that's what it's called. Ordered pairs,
0, 0.
negative pi/8 and 2. I know you're right, it's 0, 0, you are right. But a lot of times when I do ordered pairs with tangents, I'm going to start going from left to right, because that way I know that's the next furthest point I'm going to plot and all that kind of stuff. It's to be,
So 0, 0 will be the next one.
yeah. I usually plot them from left to right.
Alright, makes sense to me.
And then, it's not wrong, it's just very easy to get lost on where you're going to mark it up, that's all.
So there's only 3 first.
There's 3 of them, but you have asymptotes to worry about.
Do you want to plot those two?
Definitely do.
Every diagram, I think, is the best.
So you have negative pi/4, and then pi/4. So you still have to worry about the asymptotes about moving those, because those have to move as well. Okay.
They don't have one.
They still have the shift.
Okay.
But
To
only if
each
it's-
one of these things, we're going to move them.
Only if it's left and right, correct?
Correct. We're going to move it to the left pi/4, and we're going to move it up 3.
Okay.
So I take negative 1/8 and I subtract 1/4, so it'll be negative 2/8 minus negative 1/8 minus 2/8 becomes negative 3/8. 2 plus 3 is?
5.
Excuse me. 1/8 minus 2/8 is
Negative, yeah.
1. Negative pi/4 minus pi/4 gets you to pi/2, negative pi/2. And another one will be at 0. Very good. So what happens a lot of times with tangents, because you've got a lot of dotted lines with the parent and dotted lines for your asymptotes, it is really helpful if you have a different color, but it's not that big of a deal. You've listed them out. Place your asymptotes first. you know it's gonna be at 0, so I might make a diagonal for the new asymptote, especially it's over the origin. I'm gonna have to extend to the left, put it at pi over 2, negative pi over 2, excuse me. I know that my left breakpoint is at negative 3 pi over 8. Oops. My next point is at pi over 8. Oops, excuse me, pi over 4, somewhere up in here. Let me get this out of the way. And then the next one is at negative pi over 8 and my other asymptote. So I'm looking in this realm here now. I've shifted my period over to the left. Now just point your points. You started at 2 earlier, so you just got to move this up. 2, 3, 4, 5. Pi over 4 at 3. And then pi over 8 at 1. And I'm doing this. And it is okay that your shifted graph lines up on an asymptote of the parent, because that asymptote really wasn't there to begin with. It was there to help us place it to get the shift. That's all. So like I said, tangent graphs get messy really fast. Draw them bigger than what they need to be, and that helps alleviate some of that problem. Okay? That's really the only suggestion I can come up with. Yes.
Is the difference if the spacing between the two asymptotes is the same as it was?
Yeah. Your period is still the same. Between pi over 2 and 0 is still pi over 2. Excuse me, negative pi over 2 and 0. Yes, sir. Oh, that is. That should be good. E. These two, I believe, are just quick parent ones, and the other ones are shifted. Tomorrow we'll talk about putting everything together and a little bit about how you write equations going backwards, given a specific shift to a certain kind of a graph. See if we can write it out. My thinking as much as I want to do reciprocals prior to a test, I think we might do the reciprocals afterwards and not have them on the test itself, but do that in class maybe the Thursday before we go on break, because it's a little add-on thing, but it's something that you obviously won't see really a lot of until next year in pre-calc. I'm leaning that we could probably test either Tuesday or Wednesday then next week. We might be able to go Tuesday as opposed to waiting until Wednesday, and then we can have a little bit of leeway there in case people are dead and sick. Does that seem okay? Because I'm hoping by now, looking at the 3 different graphs that we've done, by doing all the other legwork earlier, we're learning about how the unit circle itself works. The graphing is probably pretty simple, I'm hoping.
Yeah,
Nice.
Of everything we've done, it might be the easiest, really.
It is.
That way it'll afford us a little bit of time to do the reverse versions of this stuff tomorrow. On Monday, I can get you guys some extra equation stuff and simplify. Because what I'm thinking about with the test then is to do 14, 3, 4, and graphs. So there'd be simplify, verify, solve equation, and graph.
Okay.
I think that's a pretty simple, straightforward, nothing too nutty on that.
I already my solve equation. I was like,
2 cosine squared minus 1 is 0.
I got it.
Solve for, on the interval, solve for a general solution.
Okay.
It'll say either one of those. As far as, I think that'd be pretty easy to go through. I think we could probably knock that out for either Tuesday or Wednesday. We'll see how you guys do on tangents. I think we might be able to go Tuesday. That way we have a little bit extra time if we need it. Is that all right?
Sounds good to me.
Sure.
'Cause I want to be done with all of it before you guys go to break. There's no way you're going to remember any of this over break anyway. I'll be lucky you guys remember where my classroom is. It's a week.
So we have a week off.